Hi, my name is Mackenzie. I'm a second-year PhD student in chemical engineering here at the University of Maine. I went straight from undergrad to a PhD program. I went to undergrad at Bucknell University in Pennsylvania, also in chemical engineering. I was looking for research opportunities that were in topics that I was interested in and that I felt were important to my values and how I thought the world should be moving forwards with technology and research. So University of Maine was one of those. There's a lot of environmental focus in many research topics and many of the professors who do research here. So that was definitely one of the attractive points for me. One of my friends did an REU program here a few summers ago, so I heard good things from her about researching actually with my current advisor. And I also, just looking around at the schools and their research topics and their location was kind of important to me personally. So I'm a big fan of being in Maine and University of Maine's location. I'm a big fan of canoeing, so there's a whole bunch of clubs and groups around here that make canoeing accessible to a lot of different groups of people, and so I've been making friends with those people as my sort of exercise and fun time of the day to keep myself sane. And there's hiking and skiing, lots of things that make me happy. It's definitely a very helpful environment. People are understanding that there is a balance between work and life and that there's a pretty steep learning curve coming into doing research from I did a pretty classroom-based undergrad experience personally. So having a lot of people I can ask questions for or ask questions to and who are willing to help me figure out my journey has been very helpful. The project I'm currently working on is with the Department of Energy looking at production of renewable fuels, specifically a diesel additive that is based on products that come from pyrolysis of biomass. I chose this project because it was an available project that was already in existence and something that was interesting to me within our research group. Currently, as we know, a lot of fuels are based on petroleum resources, fossil fuel resources, and that is a net movement of carbon from the ground to the air, which is bad, as we've decided, with climate change and things. But if you can use carbon that is built up in trees and other biomass sources, that is taking carbon from the atmosphere, turning it into something that you are then turning into fuels, and when you burn those fuels, it is much less of a net increase in carbon in the atmosphere. So that's an example of how I think that this project is relevant and necessary. I think it's something we at least need to try to do, if nothing else, and moving that forward is something that motivates me. Right now, I know what products can be made by another group that we're collaborating with that's doing pyrolysis of biomass. They're giving us chemicals and we know what products are in there, and then we have a goal to turn those into specific products that will be used as additives. So we're taking alcohols and acids and turning them into ethers, I think. So I'm using, this is my little gadget here that I designed, and I'm using very small batch reactors to just test the process conditions to determine what is the best conditions that I need to make our desired additive product, to make the ethers. So this is my gizmo that I have here. My reactors are this big, and so when I start my reaction, I put all of my reactants inside. I put some catalyst in there, and a stir bar, and a lid. Lids are good. And then I bring it up here, and I slide it into this box. So this box is a little thing I designed to kind of keep everything contained, and also, since it's metal, it conducts heat well enough that everything should stay pretty similar temperature, which is really important for making sure our reaction conditions are well known and documented. This here is our thermocouple. It's attached to the hot plate and stir plate, so it measures the temperature of one of the holes and regulates the temperature of the rest of the box so that everything stays at our constant temperature that I decided. This heat plate is also a stir plate, so it keeps the stir bar moving in the reactors to make sure everything is well mixed, and I'm not just kind of having layers of chemicals. And so I do that. I put the lid on just to keep everything contained and insulated with temperature. And I have a whole bunch of reactors in here. I pull them out one at a time at different time intervals and measure what's in there at the end. And using what I create over different time periods, I can learn a lot of information about rates and conditions and if I was successful in my reaction or not. So we do a lot of collaboration with other engineering disciplines and other engineering institutions and groups. So this box I designed, but the Advanced Manufacturing Center here, which works with mechanical engineering students, helped me. They built it for me, and we worked together on the design to make sure that everything was accounted for. So that was a really great collaboration opportunity to have. And we're also collaborating with other research groups and other institutions. So our biomass is being processed with the pyrolysis by a group at UMass Lowell, and then I am taking those chemicals from them and doing my portion of the project for this research project, and then that information is going to a group that designs and tests engines to look at fuels and how plausible it is to use them more in different fuels in engines. And that information is also going to another group at UMass Lowell that is looking at fuel qualities and what chemicals are desired as additives. So we are collaborating with them as we figure out what's possible and what's desired and sort of building up from there. And we're also collaborating with another student in our group at UMaine to look at how feasible the entire process is from a life cycle standpoint and economic standpoint. So if you are an undergrad student looking at graduate school at the University of Maine, I would say that you've got a pretty awesome community here. You've got lots of outdoor recreation opportunities for your spare time. You've got so many collaborators within the institution and people who have connections all over the place to help you sort of build your career path and work with your values and get some research done.